Hello, my name is Kristoffer Martinsson and I work as a field application engineer at Nohau. In this video I will show you how to create your own startup script using TRACE32. The easiest way to create your own startup script is to start with one of the example scripts that are available in the installation folder of TRACE32. This is a default installation and you see that there is a folder called demo, so let's look in here. And I have an ARM CPU, so let's look in the ARM folder and under hardware. And actually the CPU that I would like to debug is an STM32F407 device. So we should locate STM32 and F4. There are actually two different examples for STM32F4 devices, so let's just take a look at one of them. In my case, I would like to create a script that gets basic debugging working and programming on the flash, but we also would like to load kernel awareness and set up some default Windows environment in our script. Since we like to program the flash, a good starting point seems to be the one called flash. So let's copy this script and add it to our project folder. And now we'll switch to TRACE32. So the first thing I will do is actually open the script in the built-in editor inside of TRACE32. And let's take a look at the script. The first thing I'd like to verify is that we can get basic debugging working so that the communication between the debugger and the CPU is actually working. And the communication is established by using the system.up command here. So we need to verify that the settings before of that is actually correct. And the CPU selection is almost correct. Actually I have an IG device here, so let's change that. Shouldn't matter, but let's do it anyway. The next line here is very important because you have two different ways to communicate with the CPU. There is the traditional JTAG interface and you have the serial wire debug interface. Depending on your board design, you can either have just serial wire debug or you can have both. In my case I actually have both, but then we can use the serial wire debug. The next two commands is actually not very important for our case, so we can just leave them as is. So let's save our script and see by using the debug button if the script is working so far. If it's working, when we are running the system up command, we should see that the mode changed from system.down or system down to system ready. And as you can see, it was working. So we can also verify that this was working by looking at the CPU register, for example, and maybe also the list source. And actually we see something now. But this is we can see some assembler here, but this is actually a completely erased flash here, so there's nothing in it. So the next thing we need to do is to get flash programming working. So let's continue looking at our script. The next part, it seems to be that we open some dialog and asking us if we like to program the flash. We don't want to have this dialog, so just remove it. And then there is some generic flash configuration that we actually don't need to change. It should be as is. It should support all STM32F400 devices, so let's just run it as is. But here we need to change the actual file that we will load into the flash. In our case, the file will be in the debug folder and it will be called blinky.axf. So this line will actually load the content of this file to the flash. But as you can see, there is an option called no symbols, means that we will not load any symbols into the debugger. And that's actually handled a little bit a few commands later by another data.loadelf command, but actually we don't need to have duplicate commands here. We can do it by just using one command by running it like this. So in this case, this will both program the flash, so loading all the binary information to the flash, but will also load the symbols into the debugger. And the next step in the script, it will do a system.reset, because after we have programmed Flash, we would like to start from the reset vector. So now let's see if this script is working. Let's use the save button, and we can use the debug again. And this time I will not single step it, but I will just run the script until here. And now it will take a little bit more time, but because the Flash was programmed. But again, it says system ready, that's good. And we can see if we have been able to load something into Flash. So let's use list source. And as you can see here, now we're actually standing at the reset vector. And we can see we have assembler instruction, but we also see the source code. So it seems like Flash program is working, and we also see the symbols, and that's good. That means that we can debug our code. One example just you can do here is to set a breakpoint in the beginning of main function and then run to it by using the command go main. And it seems like we can execute until the main function, so that's good. So basic debugging is working. The next part that we would like to do is that we would like to load kernel awareness for the real-time operating system that we use. So let's switch back to the installation folder of TRACE32. Again, under demo and ARM, we have something called kernel. Here we can see all the operating system that's Lauterbach supports. So I'm using the operating system called RTX from ARM. So let's go in here, and I have version 5. Here are some files that we need, but it seems like we have an example here also. So let's take a look at the example. This is an example for a completely different board, but all we need is to copy the parts that actually load the kernel awareness. So let's copy this part down here and add it to our script. After we're adding it here, after we have done a reset of the CPU. So what this commands are doing are loading the kernel awareness with task.config, and then it's creating a new menu with the command menu.reprogram. And then we see that there are some more windows opening here, or more commands here for opening some windows. And actually I will just remove them, because later on I would like to add my own windows here. So let's save the script and try it out. And now we can see that we actually have an RTX ARM menu up here. So let's open some windows as we want them. So list source is a window that you should always have open. Maybe like that. And you might be interesting to look at the task that you have in your system. Right now this window is open, it is empty. That's because we have not started the operating system yet. So let's just start the execution and run for a while. Now you can see that we actually are seeing the tasks that we have in our operating systems. There might be a few more windows that you would like to have open, like break list. See the breakpoints that you have in your application or in your system. Let's reduce the size a little bit. Another useful window might be the stack. So this might be the setup that you would like to have, and for example you can set the breakpoint in some code. Let's set the breakpoint here, for example, and you can see it here, and you can try it out. And it's working, and we are in the ADC task when we're hitting this breakpoint, and you can see the task stack, and we can see the breakpoints that we have in our system. So if this is the default Windows setup that you would like to have, you can use the window button and use store Windows 2 to store it in the script, or you can use the command line, the command clip store win. And I use that, and then I will add it to my script. At the very end. But the script should always end with undo, so it must be before the undo command. So now we have a script working. Let's set up debugging, program the Flash, opening some windows and also load the kernel awareness for RTX. So I've saved it, and we can just try it out by using the file run script, or from the command line using the do command, like this. And everything seems to be working, and the script is working as is. So now we have succeeded in creating our first startup script for our system.